Hello children, today we will start new chapter that is electrolysis. So the first side heading of this chapter is introduction, and the first side heading is electrolysis. The word electrolysis can be split into electro meaning electricity and which means flow of electrons, and lysis which means pertaining to. Okay, so the phenomenon which is related with the electricity is known as electrolysis. Okay, so related with electricity is known as electrolysis. Then next heading, electrolytes and non-electrolytes. Compounds which conduct electricity when dissolved in water or in the molten state are called electrolytes. Okay, students. So electrolytes are the compounds or ionic compounds which can pass electricity through them in aqueous state or in molten state. Okay, for example, NaCl and CuSO4, while those which do not conduct electricity are called non-electrolytes. So the compounds which are not able to pass electricity through them are known as non-electrolytes. So all covalent compounds are non-electrolytes, as for example alcohol, sugar, solution, etc. Okay, students. So electrolytes are ionic compounds and these can able to pass electricity in their aqueous state or in molten state. But non-electrolytes are the covalent compounds which are bad conductor of electricity. The next heading is electrolysis, electrolytic cell. So the apparatus in which process of electrolysis is taking place is known as electrolytic cell. Okay, students. So one electrolytic cell is given here. Electrolytic cell, a non-conducting vessel containing the electrolyte in aqueous or in fused state. So electrolytic cell is made up of a non-conducting vessel which is having electrolyte and electrodes. Okay, so this equipment, such type of equipments which is made up of non-conducting vessel with electrolyte and electrodes is known as electrolytic cell. Okay, students. Now electrolytic cell is having two electrodes. The one which is known as anode, electrode connected to the positive terminal of the battery is known as anode. Okay, students. So this is the battery, and with the positive terminal of this battery, this plate is connected. So this plate is anode of the electrolytic cell, and cathode connected to the negative terminal of the battery. So this is the negative terminal of the battery, and this negative terminal of the battery is connected with this plate which is cathode of the cell. Okay, students. So cathode and anode of the electrolytic cell is depend upon that from which terminal of the battery they are connected. Okay, so if you are going to connect this plate with positive terminal of the battery, then it will become anode. Okay, students. The next point, when the switch is on, switch is there. When the switch is on, the electrolyte starts dissociating. Switch is on, electrolytes start dissociating. Current remaining The same the glow on the bulb indicates whether the electrolyte is a. So when switch is on, when this key is closed, then the flow of electricity will start through battery inside the electrolytic solution. So in that condition, due to the passage of electricity through this circuit, this bulb is start glowing. Okay, and the glow of the bulb of which type? On the basis of the intensity of the glow of the bulb, we can decide that which type of electrolyte present here in the vessel. So a strong electrolyte we can decide by bright glow of the bulb. Okay students, when the electrolyte will be strong, then high amount of electricity will pass through this circuit, and that is why this bulb will glow brightly. Okay students, then weak electrolyte, if the electrolyte is weak, then dim glow of the bulb. And if non-electrolyte solution is present, solution of any non-electrolyte is present here, then bulb does not glow. Okay students, so depending upon the glowing of the bulb, we can decide that which type of solution is taken here in the vessel in the form of electrolyte. Okay, so if a strong electrolyte is there, a bulb will glow brightly, weak electrolyte dim glow, and non-electrolyte or covalent solution of covalent compound, then bulb does not glow. Okay students, moving to next page. Terms involved in electrolysis. So this page is related with the basics of the electrolysis process, the terms which we used in electrolysis process. So electrolysis is the decomposition of a chemical compound, electrolyte, in the aqueous or fused state by the passage of a direct electric current, resulting in the discharge of ions as neutral atoms at the respective electrode. Okay, so this is the definition of electrolysis. Okay students, so what is the definition of electrolysis? What changes are taking place in electrolyte? So electrolysis is the decomposition, is the type of decomposition reaction. Okay, so the breaking of the compound in the presence of electricity is known as electrolysis. Okay, so electrolysis is a type of decomposition of a chemical compound, and that chemical compound should be electrolyte or ionic compound in aqueous or fused state. Okay, so this state you keep in your mind that electrolytes pass electricity through them only in aqueous or fused molten state. Okay students, by the passage of a direct electric current and the formation of ions. So with the in the influence of electricity, ions will form, and the ions will form first, ions get separated, and then they will be discharged as neutral atoms at the respective electrodes. For example, decomposition of electrolyte in aqueous or fused state by passage of electric current. We can take example of NaCl. So NaCl is an electrolyte, and this will dissociated in the form of ions Na plus and Cl minus. Okay students, due to the passage of electricity, Na plus ion start moving towards the cathode, because cathode is a negative electrode of the electrolytic cell, and the negative ion will start moving towards the anode, because anode is positive electrode. So positive ion will start moving towards the negative pole of the cell, and negative ion will start towards the moving positive electrode of the cell. So at negative electrode, which is cathode of the cell, sodium positive ion will take electron and change themselves in the form of sodium atom. So in this reaction, in this conversion, gain of electron, sodium is accepting one electron. So all such reactions in which gain of electron is taking place are known as a reduction reaction. So at anode, a reduction of sodium plus ion is taking place. At cathode, reduction of sodium plus ion is taking place. Okay, students, and same time at anode, chloride ions are evolving one electron and they get converted in the form of chlorine atom. Okay, so removal of electron is known as oxidation. So at anode, oxidation is taking place by loss of electron, and at cathode, due to the gain of electron, reduction is taking place. Okay, students, then after this, electrolysis involves a chemical change and is a redox reaction. So as you can see here that in whole electrolysis process, sodium ions get reduced in the form of sodium atom and chloride ions oxidize in the form of Cl atom. So both reduction and oxidation reactions are taking place simultaneously. That is why electrolysis is a type of redox reaction. Okay, students, so such reactions in which both oxidation and reduction is taking place simultaneously are known as redox reaction. So electrolysis is an example of redox reaction. The next heading, electrolytes and non-electrolytes. So differences between these two types of compounds. Electrolytes, chemical compounds which conduct electricity in the fused or in aqueous solution state and undergo chemical decomposition due to the flow of current through it. Okay, so electrolytes are the compounds which pass electricity through them in their fused or in aqueous state and undergo chemical decomposition are known as electrolytes. So electrolytes are ionic compounds, chemical compounds which do not conduct electricity in their fused or aqueous solution state and do not undergo chemical decomposition due to the flow of current through it are known as non-electrolytes. And non-electrolytes are covalent compounds. So electrolytes are ionic compounds and non-electrolytes are covalent compounds. Now particles in electrolytes are ions only. Okay, are ions only or ions and molecules only. But in non-electrolytes, molecules only. So particles in non-electrolytes are molecules only. Example of electrolytes: mineral acids, alkalis, KOH, NOH, ionic salts like lead bromide, copper sulfate. And non-electrolytes, all organic compounds. All organic compounds are non-electrolytes. Alcohol is an organic compound. Glucose, organic compound. Sucrose, organic compound. These all are non-electrolyte. And few inorganic compounds like carbon disulfide, liquid carbon tetrachloride, these are also non-electrolyte. The next heading is strong electrolytes and weak electrolytes. So according to the first point, in a strong electrolyte, they are electrolytes which allow a large amount of electricity to flow through them and hence are good conductors of electricity. So strong electrolytes allow high amount of electricity to flow through them. Okay, and that is why these are good conductor of electricity, whereas weak electrolytes are poor conductor of electricity. Why? because these allow only small amount of electricity to flow through them. Then second point, strong electrolytes are almost completely dissociated in fused or aqueous solution state, but weak electrolytes partially dissociated. And okay students, partially dissociated, strong electrolytes completely dissociated. Then particles in strong electrolytes, mainly ions only, okay, because all molecules will dissociate in the form of ions. So in the case of strong electrolytes, the particles which are present in the medium will be ions only, but in the weak electrolytes, due to partial dissociation, ions and unionized molecules both will be present. Examples: generally all strong acids and bases and most salt of strong acids, like all dilute acids, mineral bases like sodium hydroxide, KOH, LiOH, etc. Salts, NaCl, sodium sulfate, sodium nitrate, lead sulfate. These all are strong electrolytes. And weak electrolytes like carbonic acid, acetic acid, oxalic acid, formic acid. Bases like ammonium hydroxide. Salts like sodium carbonate, bicarbonate, etc. So these are the examples of weak electrolytes. Okay students, this much in this lecture. Thank you.